Hello, welcome to the class. Let's dive into the problem. As shown in the figure, 5 Carnot engines, each with efficiency eta and same number of cycles per unit time, are operating between 6 heat reservoirs. The amount of the heat released per cycle by one engine is completely absorbed by the next engine. Consider Q0 to be the amount of heat absorbed per cycle by the first engine and W as the amount of the work done by the all engines per cycle. Then the net efficiency of the system is found to be eta net, that is equals to W by Q naught, that is equals to 211 by 243. Then the value of eta is should be fine. For this, let's have a look on the picture that shows the Carnot engines. Here in this picture you have 5 Carnot engines, 1, 2 and it follows up to 5 engines. By the definition, what is a Carnot engine? Carnot engine, it absorbs the heat from the heat reservoir, that is called source, and it does some work. After that it compressed in order to get some heat, and that heat again converts into the heat source. So that in this cycle also, here if you observe, Q naught is the heat source, and it by observing the heat Q naught, it does some work W1 and it rejected heat Q1 here, and this Q1 heat absorbs by the second engine. This Q1 is acts as a source for the second engine. It does some work W2, and after that it rejected Q2 heat, and Q2 heat absorbed by the third engine. It follows up to the 5 engines. Okay, now let's find what is the value of eta in these 5 Carnot cycles. Let's go for the solution. Okay, in the cycle we have seen in the first Carnot engine, the eta formula we know that 1 minus Q out by Q in. Okay, what is the Q out in the first engine? Q out is Q1, the heat rejected by the engine Q1, and the heat absorbed by the first engine is Q naught. From this you get eta minus 1 is equals to Q naught minus Q naught over Q1 over Q naught is equals to 1 minus eta. From this you can get Q1 is equals to Q naught into 1 minus eta. This is fun. Next, go for the second engine, second Carnot engine. The second Carnot engine, again eta is equals to 1 minus Q out by Q in. In this 1 minus, what is the Q out here? In the second engine, Q out is the Q2. Q in is the Q1. Okay. The heat absorbed in the second cycle is the Q1. So from this again Q2 by Q1 is equals to 1 minus eta. From this Q2 is equals to Q1 into 1 minus eta. Here you get Q1. From the equation 1, you can write a Q1 in the place of Q1. You can write Q naught into eta minus 1. Q2 is equals to Q1 into 1 minus eta. In the place of Q1, I am substituting Q1 value here. Q naught into 1 minus eta into 1 minus eta. This implies Q2 is equals to Q naught into 1 minus eta to the power of 2. For the third engine, third Carnot engine, what is the efficiency? Eta is equals to 1 minus Q out by Q in. For this, again Q out by Q in is equals to 1 minus eta. From this, you can get Q. What is the Q out for the third engine? Q3 by Q2. This implies Q2 1 minus eta. Q3 is equals to Q2 into 1 minus eta. Again, the Q2 value what you have arised here, you can substitute here. Q naught into 1 minus eta square into 1 minus eta. From this, what is the value? Q3 is equals to Q naught into 1 minus eta to the power of 3. It follows for the fifth engine. It follows for the fifth engine. Okay, Q naught. What is the value you get? Q naught into 1 minus eta to the power of 5. Okay. And what is the W net they have called? W net. Total work done in that 5 cycles is equals to W1 plus W2 plus W3 plus W4 plus W5. That is equals to the heat transmission, the work done in that engines. That is the work it done by the heat transmission from the heat source. Okay, the heat is converted into the work. So that what is the heat transmission in the Carnot cycle? First Carnot cycle, Q naught minus Q1. In the second, Q1 minus Q2. Plus in the third engine, Q2 minus Q3. Okay, the heat difference, it converts into the work. So that I'm writing the heat difference in that engine converts into the work. So that I'm writing for the W1, I'm writing Q naught minus Q1. For the W2, I'm writing Q1 minus Q2. It follows Q4 minus Q5. If you closely observe, all these values will be cancelled out. Okay, you get Q naught minus Q5. Okay, the W net. The total work done in that cycle, it depends on the initial source and the last engines, that the heat which rejects. Okay, in these factors only the W net is depending. Okay, from this you can get what is the W is equals to Q naught minus Q5. In the place of Q5, I'm writing Q5 value here, Q naught into 1 minus eta to the power of 5. From this, let's take out the Q naught out and 1 minus eta to the power of 5. W is equals to Q naught into 1 minus eta to the power of 5. Okay, from this W by Q naught. Okay, what they have mentioned, the total W by Q naught is equal to 1 minus eta to the power of 5. From this, you can get 1 minus eta to the power of 5 is equals to 1 minus W by Q naught. Okay. Here is the value 1 minus W by Q naught they have given. How much in the problem? 211 something. No? $211 by 243 W by Q naught. Okay. W by Q naught 211 by 243. From this 243 minus 211 is equals to 243. This is equals to 1 minus eta to the power of 5. Okay. From this you can get 243 minus 211. You get 32. 32 by 243. From this 1 minus eta to the power of 5 is equals to 32 by 243. Okay. You can write 32 as a 2 power 5 and 243 as a 3 power 5. Okay. 1 minus eta to the power of 5. Okay. 1 minus eta to the power of 5 is equals to 2 by 3 to the power of 5. 5 cancel here and you get 1 minus eta is equals to 2 by 3. This implies eta is equals to 1 minus 2 by 3. From this you get 3 minus 2 by 3 and eta is equals to 1 by 3. What is the value? The efficiency. The efficiency of the engine is 1 by 3. Okay. It always the efficiency of the engine theoretically we have seen it is less than the 1. So that it is you get eta is equals to 1 by 3. This is the answer. Thank you for watching. Thank you all.